So we are on the homework assignment for lesson 3.3 in the textbook, and we are starting on number 1. So it asks, why are the equations below called equivalent equations? So we've got 3 of them if you take a look. 2x plus 5 equals 11, 2x equals 6, and x equals 3. And you notice how I wrote it. I spread them out like this instead of stacking them up so that I can work right underneath of it. So let's start with this first one. If I was going to solve this, I would minus 5 from both sides. I get 6, and right away you should notice that these look the same. I would divide by 2, which is the same thing I would do here, which gets x by itself and leaves me x equals 3. And so you can see all 3 of these equations end up with x equals 3. So now we have to actually answer the question, why are these called equivalent equations? It's because they have the same solution, same answer, however you want to say it, which is x equals 3. So number 2, what equation is represented by the diagram? So you can see we have 3 x's on this side, plus this 1 extra ounce. And on the other side, if you count it up, we've got 7 ounces. So 3 boxes, which are your x's, plus 1 ounce, is equal to, because they're balanced, one's not weighing more than the other, they're equal to 7. So these 3 boxes somehow equal this out, where I only have 1 ounce on this side and 7 on this side, but these 3 boxes balance it out. So letter B, what 2 steps can be made with the weights on each side of the scale to find out the weight of a single box? First of all, you want to take 1 ounce off both sides. We want to get this out of here, so we just have boxes. And if we just took this off, all of a sudden the other side would be too heavy. So we have to take 1 ounce off both sides. So we're going to take 1 ounce from both sides. And then think about what's left. You're going to have 3 x's and you're going to have 6 ounces. And so we want to take off 2/3 of that, meaning leave 1/3 of it. So we're going to leave, because we have 3 boxes, we just want 1. So we're taking away 2/3 of the boxes, 2 out of 3. We're leaving 1 out of 3, 1/3. So we want to take away 2/3 of the 6 and leave 1/3 of the 6. 6 divided by 3 is 2. That's 1/3. So we're going to leave 1/3 of the weight on each side. Now that would be like dividing by 3, and that's 1/3. Dividing by 3 is the same as multiplying by 1/3. So we're taking 1/3, we're going to leave 1/3 of the weight on each side. And if we actually did that, we would minus 1 from both sides and get 6, and we would divide it by 3 to get 1/3 of it, and you end up with 2. And in this specific equation, the 2 represents ounces. All right, number 3. Filling in the blanks. When we're solving this equation, 5x minus 27 equals 13. First, we want to get rid of the minus 27. So we are going to add 27. And then after we do that, we're going to have 5x equals whatever. The next thing we're going to do is we're going to divide both sides by 5. Divide by 5. So for part B, that was A. They actually want you to solve it and check your result. So let's finish this solving out here. If I add this, I get 40. And then 40 divided by 5 is 8. Now when you check it, you plug your answer back in. So 5 times 8 minus 27 equals 13. This should come out balanced. You're going to get 40 minus 27 equals 13. 40 minus 27 is 13. Both sides come out balanced or equal. Our check works. We're good to go. Okay, number 4. We're going to consider the steps right here. What was done to go from the given equation, the whole big equation here, to step 1? How did we get from here to here? So I'm not even going to write that one out. You can just see 82n is now by itself. The minus 51 went away. This went up by 51. So they added 51 to both sides. And then letter B, what was done to go from that step to here? So the 82 went away. That was multiplication, 82 times n, so you divide to get rid of it. And if I divide 492 by 82, I get 6. So divided by 82 on both sides. Number 5. Equations are given. Determine what was done to each side of the first equation to arrive at the second. So you don't have to finish these out. You're just going to say what happened. So to get from here to here, the minus 11 went away. That means we added 11 to both sides. Number 6. Take a look. The 72 went away. Now, when people see minus, they want to say that you added something. But this minus is with the 18t, and we're not doing anything with that right now. We're just affecting the 72. So this is a positive 72. If I want to get this down to a 0 and make it go away, I have to minus 72. And if you look at the number on the right, 864, I didn't add 72 to it. It would have gotten bigger. I subtracted 72. And again, the reason is because it was a positive 72. So the minus doesn't go with the 72. So we're not going to look at that and say plus, because if I added 72, it doesn't go away. It just becomes a bigger number. I need it to go away. I need to get it to 0, so I minus 72. Okay, number 7. 3/5 went away. It was multiplication. So there's two ways to do this. You could divide by 3/5, because this is 3/5 times n, so you divide to get rid of it. But we also know that dividing by a fraction, how do we divide by a fraction? We flip it and multiply. Keep, flip, change. Flip it and multiply, and that is using the reciprocal. So you also could say multiply by the reciprocal, which is 5/3. So either one of those is acceptable. If you were using your calculator, if you divided both sides by 3/5, 3/5 divided by 3/5 is 1, it goes away. And if you do 30 divided by 3/5, you'll get 50. But if you multiply by 5/3, think about the 5 times the 3 on top and the 3 times the 5 on the bottom. You'll get 15 over 15, which is 1, and it goes away. And if you multiply 30 by 5/3, you also get 50. So these say the same thing. Dividing by 3/5 is the same as multiplying by 5/3. Either answer is good. Okay, number 8. What might be done first? Oh, right here first. So this is a big decimal, but it's being multiplied by v. So to get rid of it, I'm dividing. So just divide by 0.004. Okay, number 9. What might be done first to each side of this to begin the process? So there's different ways to do it, but the general way that works every single time, which is the way that we're going to stick to, is you're going to get rid of this lonely number, this number by itself. We're not going to deal with the x first. We're going to deal with this. So it says minus 100, so this counts as a negative 100. To get it to 0, I have to add 100. Okay, next up was number 12. So a student had this equation. Their work is shown. They said x equals -3, but if you substitute -3 into the original, it's not true, which means they did something wrong. The check doesn't work, so part of their work is wrong. So what did they do wrong? So if you take a look, here's the starting point. That's the given. On step 2, they minused 32 from both sides. So 20 minus 32, that's -12. But over here, if you had a -32 and you minused 32, you don't get 0. -32 minus 32 is -64. So really, this should have said 4x minus 64 if you did this correctly. So they chose the wrong step, and not only did they choose the wrong step to do here, they did it incorrectly even at that. They should have gotten a different answer. So what did the student do wrong? They subtracted 32 instead of adding 32. So this counts as a negative 32. If I want to get it to 0, I have to add 32. All right, next up was 14. Go into some review. So we've got this equation. We're going to complete the table at the right. Let's start there. So negative 2, negative 1, 0, 1, 2. And so y equals 7x minus 2. I'm going to start with 0. If I plug 0 in for x, 7 times 0 is 0, minus 2 is negative 2. Plug 1 in. 7 times 1 is 7, minus 2 is 5. Plug 2, 7 times 2 is 14, minus 2 is 12. Okay, on to the negatives. Negative 1 goes in. 7 times negative 1 is negative 7, minus 2 is negative 9. Negative 2 goes in. 7 times negative 2 is negative 14, minus 2 is negative 16. And of course, you can use your calculator there. So part B, use the table to find a solution to the equation. When does 7x minus 2 equal negative 16? Right here. So part B, this is where we found the answer. It's when x equals negative 2. All right, and then the last question that we had to do here was number 17. So, Death Valley, California once reached this record high. Suppose the temperature was 85 degrees at 9 a.m. and then increased by 7 degrees every hour till 4 p.m. when it reached that record high. Part A, use this information to complete the table at the right. So we've got time, and we've got degrees Fahrenheit, 9, 10, 11, 12, 1, 2, 3, 4. So starting here, the starting temperature, they said, 85 degrees at 9 a.m. And it's going up by 7 degrees every hour. So by 10, we're going to go up 7, that's 92, plus 7, that's 99, plus 7, that's 106, 113, 120, 127, and then 134. Okay, part A was to complete the table. We got that done. And then they just want you to graph it. So all positives here, meaning I can just make a one quadrant graph to represent my positives. We're going to have time go across the bottom. So we're not actually starting at 0. We're going to start at 9 o'clock, and 10, 11, 12, I almost said 13. 1, 2, 3, 4. Now we don't have to start at 0 here. Okay, you can start at a different number. You'll notice on the answer key, it's got this goofy little thing here, and that's to show you that we're not going from 0 to 80 in that little bit of span, because that means we would have to count by 80s. And you can see they counted by 5s when they did it. So that's kind of how they do that little part of the graph. But we need to go all the way up to 134. So I think for consistency's sake, we should start at 0. And let's figure out something good to count by. Let's say 25. 25, 50, 75, 100, 125, 150. To me, that makes sense. We get high enough to cover the numbers that we're going to have to represent here. And we don't get there so fast that they're going to be all smushed in. And so we have a starting at 9 o'clock of 85, so a little bit above 75. At 10, we've got 92, 11, 99, just below that 100. 12 with 106. Now you should try and be putting these in a line, because if it's going exactly up by 7 every single time, that's linear, it will form a straight line. So if something's not forming a straight line on your graph, you know something's wrong. Let's see where we're at. 2 o'clock, we're at 120. And then we're at 127, and then 134. Now, is there time between these? Is the domain just integers, or is it all real numbers and we should connect these dots with a line? And I would vote that we should probably connect them, because the temperature is rising in between. And if it's steady, we could connect it. You'll notice that on the scatter plot that's given to you in your answer key, they do not. And that's probably simply just a decision made because we don't know if it was steady in between. It could kind of go up and down, I guess, theoretically. But since this is rising so consistently and there is time between 9 o'clock and 10 o'clock, it doesn't just wait till 10 o'clock and then jump up and then jump up, right? So I'm okay if you connected this. Okay, we don't know if this is going to keep going, so I wouldn't put an arrow here. We don't know if it's going to continue. It could go down after that. But we know from here to here it was a steady rise, so I'm okay with connecting it. Obviously, the answer key just has dots, so that's fine too in this case.